Good morning, guys. Hello. Good morning. Good morning. Thanks for coming. Thanks for signing in. We're just gonna wait one more minute and let people kind of come in, and then we'll go ahead and start, okay?
Got your hair?
Good morning. Hi, guys.
Yep.
Hi, Zachary is awesome.
Well, I'm not Zachary.
You're not
Zach
Zachary.
always changes his name always to Zach.
Oh, I see. I see. All right, we're gonna give people a couple more minutes, then we're gonna go ahead and start. All right.
Actually, my name's Josh Day. It's not Zach is awesome.
My name is Josh. Okay, cool. I'm glad you fixed that now. So now I know, and I got it all straightened out. We're gonna give people. There are a couple more people that signed up, so I'm gonna give them one more minute to join in, and then we'll go ahead and start. All right. Let me see. Maybe if I lower the umbrella. So, I think we're going to go ahead and start because I want to be respectful of everybody's time. So, hello, guys. Welcome to Summer Science. If you've been here before, you kind of know how it works. Basically, I'm going to take a question that somebody asked in past weeks, and I'm going to try to answer it, and we're going to do an experiment, too, to answer it. So it's really fun, really chill. Just sit back and watch, and hopefully you guys learn something good, okay? So I'm going to shift now so you guys see my PowerPoint, and we're going to go through what our question is today, because I think it's kind of an interesting one. So yeah, I'm going to go ahead and switch. I will be back for the experiment, guys. Here we go. Cool. All right. And we may get some more people that join in as we go, but that's okay. They should be able to join in. So today, what we're going to look at is the question, sorry, I'm just trying to adjust something. How do gemstones form? Okay. I got this question a couple weeks ago, and I was thinking about it. I'm like, man, that's kind of an interesting question because it's something that we have, that we see. You know, you guys have seen rubies and diamonds and gemstones like that, but you probably don't know how they form. So we're going to kind of go into detail about how that works and how that process works. Okay, so to start, if we want to figure out anything about gemstones, we have to start by looking at the structure of Earth, okay? And maybe you've heard of the structure of Earth before, but basically Earth is made up of a crust, an outer crust, a mantle, an outer core, and an inner core. So if you were to kind of slice Earth in half, like a, I don't know, like a piece of pie or something, you can see all this stuff on the inside. So you see the crust, the mantle, the outer core and the inner core. So the crust is about 3 to 25 miles deep, depending on where you are at. So it's pretty thick. When we get to the mantle is very thick. The mantle is 1,860 miles thick. Okay, so think how thick that is. And this is really the biggest part of Earth. It makes up about 83% of Earth's volume. Huge, okay? So this is really, really big. You can think, you know, maybe you've walked a mile or something, or walked 2 miles. Now think about this as 1,860 miles. It's really big. So when we're talking about gemstone formation, really the only pieces we're going to be worrying about are the mantle and the crust, these two outer layers, okay? The crust on the Earth and the mantle. That's all we're going to be talking about today. Okay. So now, we're going to look at and say, okay, what are the different types of gemstones that we need to know? Because there actually are a couple of different types. So there's 4 different types of gemstones. We're actually going to talk about the main 3, because the fourth one's kind of, we don't really need to know it. So gemstones, when I'm talking about gemstones, basically they are cut and polished rocks, okay? So gemstones come from rocks. It's just when you take a rock and you kind of shine it up, you polish it, you get rid of the dirt, then you're able to produce a gemstone. And so basically if I say rocks, right, know that rocks and gemstones are the same thing. It's just that gemstones are a rock that's kind of been bedazzled and polished up, okay? That's all a gemstone is. So if we want to learn about where gemstones come from and how they form, we have to look at where rocks form. That's really their parent, how the parent forms. So there's a couple of rocks. There's igneous rocks, there's sedimentary rocks, and there's metamorphic rocks. And you probably don't know how these form, and that's okay. I'm going to show you how they form and how they actually build off of each other to form this really cool thing called the rock cycle. But we're going to just start by talking about igneous rocks right now, and then we'll go on to the other ones. Now remember, rocks are, a polished rock is a gemstone. So rocks and gemstones are equivalent, okay? They're the same thing. Okay, so how do igneous gemstones form? Okay, if we want to think about this, basically igneous gemstones in the crust, where the crust and the mantle meet. So remember I was talking about the mantle and the crust right here. This is just kind of like if we were to zoom in really close, you'd see this is the crust and this is the mantle. Now, where they meet, guys, there's really high pressure and it's really, really hot. So that this line right here, it's really high pressure and it's super duper hot. The Earth's crust is actually broken up. I'm sorry, there's a plane talking. The Earth's crust is actually broken up into sections. They're called tectonic plates. Okay, you may have heard of that before, especially during earthquakes. Basically, they make it like the Earth's crust is broken up into these puzzle pieces. It's not just one big, nice, like pie crust. It's like broken up, but they all kind of fit together. All the pieces of the crust fit together. So each plate, each little tectonic piece does not float on this mantle. Like the mantle is like holding up the crust. The plates can push into each other and they can also push down into each other. So they can kind of push together. If they push, they meet up, or they push, and they go down. And that's how we actually get mountains and valleys to form, okay? It's the pushing of the plates together. Also, magma is moving. So in the mantle, right, the mantle is filled with magma, okay? So mantle, magma kind of helps because they both start with Ma. But the mantle is filled with magma, and that magma ends up moving. And a lot of times it ends up wearing away the bottom of the crust, and that's why we get these fractures and cavities, guys. It's because this hot magma is flowing really rapidly through the mantle, and it's kind of like breaking apart. It's kind of like putting some friction on that mantle. So cooling magma that comes from the mantle, that is what forms igneous gemstones, okay? And there's 2 types of cooling processes, so we end up with 2 types of igneous rocks / gemstones. So basically what happens is liquid magma, it's super duper hot in the core of the Earth, okay? As you get closer to the core of the Earth, it's gonna get hotter. And liquid magma from the mantle, when it comes up through the crust, okay, it ends up cooling off. And it cools as it comes up through the crust and to the surface of the Earth, okay? So magma comes up out of the mantle, and usually the way that it comes up to the crust of the Earth is through volcanoes, okay? They are holes that kind of connect the mantle to the crust. So magma, like in this picture, magma is able to come up, cool off, and be spewed out of the volcano. Now, that is what forms what we call extrusive igneous rocks, okay? Extrusive igneous rocks are when magma comes out of the volcano, it touches the crust, and it cools off, and it forms a rock, okay? But it's already hit our atmosphere. It's come up through the volcano, hit the atmosphere, and cooled off. That's what we call an extrusive igneous rock. Now, intrusive igneous rock, this is another type of igneous rock, but this happens when you have magma that's coming up, right? It's leaving the mantle, it's trying to get out, but it ends up getting trapped, okay? And it doesn't completely cool off and solidify. It kind of takes a long time because it's closer to the earth. Remember, the closer to the center of the earth that we are, the hotter it is. So intrusive igneous rocks, those just get stuck. They get trapped inside the crust and they're not released from the crust, they're trapped inside the crust. And it takes them thousands of millions of years to cool off and solidify, to completely cool off, because they haven't hit our atmosphere. The atmosphere is much cooler than the inside of Earth. So if we're looking at now, like what's the difference between the rocks? Like you're saying they form differently, how are they actually different? So this is an intrusive igneous rock right up here that I have my cursor on. Because these rocks cool super duper slowly, the minerals inside the magma, and minerals, guys, minerals are just like little crystals inside the magma. So magma comes from the mantle, it's filled with these like little crystals we call minerals. Minerals from the magma, they have a lot of time to grow and to just sit around and kind of hold their shape, okay, when they're intrusive, because it takes them a longer time to cool. So they end up being really grainy, whereas extrusive igneous rocks, guys, they cool super duper quickly. Those are the ones that just kind of explode out of volcanoes. They cool off like instantly because the earth, the atmosphere is so cool compared to the core of the earth. The minerals don't have time to grow, so they have a really fine texture, and they also might have bumps and little bubbles because they cooled so quickly, and the magma, sometimes magma bubbles will get trapped, okay? So just remember that there's two different types. We have magma is going to leave the mantle, hot magma, and then it ends up cooling off when it reaches Earth's atmosphere. But if it doesn't cool off, right, it's because it's been trapped inside the crust and it takes a longer time to cool off. And remember, the closer you are, as we get closer to the crust, we get cooler. As we get closer to the core, we get hotter. So that's why this guy is going to be hotter than this one. Okay, so now we kind of talked about igneous gemstones. Now we're going to look at sedimentary gemstones. Okay, it's another type of gemstone, just another breed that we need to understand. So when we have igneous rocks, guys, when igneous rocks reach the surface of the earth, okay, so when they reach up here, we see the igneous rocks, we can see them, they start to face erosion and weathering. So you may have heard of what erosion is, but erosion is basically when wind and water, they pull soil, rocks, and dust from one location to another, okay? So you have air, and also then we have weathering too. So weathering is when air and wind, they wear away at something. So I really like this picture here because it shows these different layers, the intricate different layers of this rock. And the reason that the different layers are exposed, guys, is because of erosion and weathering. Air, wind, and water, they're scraping that rock. They're pulling off little pieces and pieces of rock. It's like, right? They're pulling those off. And basically, when air, wind, and water, when they move across igneous rocks, which we just talked about, right? When those air, wind, water, when they're moving across igneous rocks, they end up carrying particles across them, and it kind of scratches up the igneous rock. And the top layer of the igneous rock is just going to kind of break off. Okay, so it breaks off into these itsy tiny pieces. But air, wind, and water, guys, they kind of scrape across the top of the igneous rock, and it starts wearing away the top, and those little top particles kind of end up floating around in Earth. So eventually, the sediments that we pull off of the igneous rock, they end up packing up, and they build up on either land or underwater. So imagine, you know, this might be happening. Let's say we have one igneous rock. We have a windstorm. The wind is pulling at the igneous rock. It's breaking off that top layer. Well, this could be happening to millions of igneous rocks around the world. So when we have that, right, those sediments, guys, they end up packing up on each other, and they build up because you get more igneous rocks. You get more sediment. And sediment is just that scraping that we get. And once we build up enough sediment, the top sediment ends up packing down the bottom sediment, okay? It's like we have layers of like igneous rock dust, and the top layer is going to be heavy enough to push down on that lower layer. And then what happens, guys, is that compression ends up producing what we call sedimentary rock. And sedimentary rock, also there's some chemical and physical changes that are happening, but the main thing is that igneous rock dust or sediment packed together is what forms sedimentary rock, okay? So sedimentary rock is kind of like the mixed rock. Like it's made up of all this like igneous rock scrapings that we get. It kind of packs together and we form this new type of rock called sedimentary rock. And same thing here, you guys can see, right? The rocks have been worn away at, like you see that we have erosion taking place. That's why the layers of the rock are exposed, is because it's like water down here, guys. The water is rubbing away at that top layer of the igneous rock. And it carries those particles, they start to pile up, and then you produce sedimentary rock. Okay, so kind of cool. So the last rock we're going to talk about, or last gemstone we're going to talk about, is metamorphic gemstones. So metamorphic gemstones are igneous or sedimentary rocks. They can be either that have changed in some way due to high heat, high pressure, or an injection of a fluid with minerals. So basically metamorphic rocks are just taking your igneous or sedimentary rocks and you change them up through pressure, through heat, and then you produce metamorphic rocks. So pressure and temperature that are placed on igneous or sedimentary rocks can cause them to be compressed, or they can spread them thinner, or they can cause them to rearrange their mineral composition. You guys remember those minerals are basically those little particles that are found in the magma of rocks. Okay, so the only thing about metamorphosis that we have to remember is that it actually does not end up melting rocks, okay? So if this is a sedimentary rock and it goes through metamorphosis, it's not gonna end up melting completely. It's just gonna end up changing its form in some way. So there's a couple of different types of metamorphic rocks. There's foliated metamorphic rocks, which those are the ones that you guys see. It looks like they have stripes here. And basically, the reason that they have stripes is that when we put pressure on the rock, you see, oh, geez. Oh, okay. So when you put pressure on the rock, guys, it causes the minerals to come together in like bands, almost in stripes. There's non-foliated metamorphic rocks. I don't have a picture of those, but non-foliated metamorphic rocks will not have any stripes. And that's just because even though you put pressure on those minerals, they're not going to form and collect together into bands. But with foliated metamorphic rocks, they do come together in these like striped bands. So basically, just remember, metamorphosis doesn't melt the rock. We're just changing the way that the rock is shaped or the mineral composition of the rock, either through heat, like we're putting heat on the rock, we're putting pressure on the rock, or we're just adding minerals to the rock. And that happens if we have mineral fluids that are floating around. They can sometimes infiltrate into the rock and cause it to change its composition. So basically, guys, just understanding that metamorphic rocks are just sedimentary and igneous rocks that have kind of changed around a little bit, kind of like Play-Doh. Okay, so now you're probably wondering, you're like, all right, you talked about how these rocks form and this idea of the rock cycle, but what are some examples of igneous gemstones? So a couple of igneous gemstones are, we have amethyst, citrine, ametrine, garnets, moonstone, apatite, diamond, spinel, tanzanite, tourmaline, topaz, and zircon. I included tanzanite, moonstone, and topaz here just so you guys can see it. But basically, these are gemstones that we have extracted from igneous rocks. So when we have igneous rocks, if it were my guess, most of these gemstones form from extrusive igneous rocks that we're able to get from the Earth's crust. After a volcano, you have magma that cools, right? If you kind of polish up that magma, you can find these gemstones inside of igneous rock, okay? So now let's talk about what are some examples of sedimentary gemstones. So sedimentary rock, remember, that's that rock that we were scraping off the top layer of the igneous rock. We're building up sediment, we put pressure on it. That's how we form sedimentary rock. Some gemstones that we can get from that are opal, malachite, chrysoprase. We also have beryl, opal, quartz, azurite, chrysocolla. So some of these you may have heard of before, but I'm just showing you a couple of pictures here. So you can see that actually, even though those rocks are kind of ugly, we can take them and make them really beautiful when we polish them up. And that's how we get these really unique gemstones. Okay, and then lastly, let's talk about some examples of metamorphic gemstones. So a couple of metamorphic gemstones that we have are beryl, jade, lapis, lazuli, spinel, ruby, sapphire, and zircon. So here I put a couple of pictures of those. And again, guys, these are just when we have those sedimentary rocks or igneous rocks and somehow they change their shape around through heat or pressure. We kind of squeeze them, squish them, spread them out, something like that. We get metamorphic rock. And if we polish up that rock, guys, we can get these gemstones, which are really beautiful. Okay, so I hope that kind of makes sense. Now you understand where all these gemstones come from because they are different. They come from different places. but it's the idea of how rocks form that is what produces them. So I always like kind of giving you guys something to chew on at dinner, because it's so important in my eyes, for you guys to understand, like, how do I discuss this with other people? How do I become a really good scientist to discuss with other people and to share my ideas with others? So the question I want you guys to talk about tonight is this: if you could change the rock cycle in any way, what would you change and why? What would you change about the rock cycle? Would you change the way that sedimentary rocks are formed? Would you change the way that igneous rocks are named? Right now it's kind of set in stone, no pun intended, but how would you change the rock cycle? What would you do to change it up a little bit? Okay, so that's just a question for you guys to think about. Hopefully you can take some of the knowledge you learned today and apply it to this question. So now what I'm going to do is I'm going to exit my sharing screen here, okay? And I'm going to go ahead and turn on to our experiment. I'm going to show you guys a cool experiment we're going to do today. So basically, can you guys see my face now? I think it's on, right? Yeah. Okay, cool. So basically, what I'm going to show you guys today is we're going to look at erosion. And remember, erosion is that thing I was talking about where you have wind and water are rubbing away at the top layer of a rock, and they end up pulling the top layer apart and ending up with these little particles. So the experiment today we're going to test is water erosion or wind erosion most effective? Okay, and you guys can make some predictions about which one you think is going to be the most effective in spreading the rock particles and really breaking off the most rock particles. Okay, so what I'm going to do is I'm going to actually pull down my umbrella so you guys can actually see what I'm working on here. And I'm going to show you how I'm going to set this up. Okay. So for today, what I have for you, I'll move over a little bit. So what we're going to look at is, so basically, guys, what I did was I created a replica of 3 rocks. So what I did was I made a replica of 3 igneous rocks, all right? And, okay, good, now you guys can see me. So I made a replica of 3 igneous rocks, and all I did was this. I'm gonna lower my camera here. You guys can see I took a pile of dirt, okay? And dirt is to represent an igneous rock with the different layers. It's kind of been formed now. And we're gonna look at whether blowing, wind, by blowing through the straws, guys, equate, like, it's the same as wind. We're going to pretend for this experiment. But if I blow wind at the igneous rock, is that going to make the most sediment? And remember, sediment is that top layer. Or if I spray my igneous rock with water, is that going to make the most sediment? Or if I put a glacier, which is going to be an ice cube, I put a glacier on my igneous rock, is that going to produce the most sediment? And remember, guys, water and wind or air, you can call it, that is what produces sediment from igneous rocks. We're going to see which one is the most effective in producing sediment. So,
how long does it take for actual rocks to form?
Sorry, one more time, what'd you say?
How long does it take for actual rocks to form?
Oh yeah, so for actual rocks to form, it's going to take millions and millions of years. Okay, rocks are not something that formed yesterday. It takes millions of years to get rocks to form, and especially to change form. If we're going from an igneous to a sedimentary rock, it's going to take a long time. So right now, what I'm going to do, guys, I'm going to go ahead and test this out, and you guys can make some predictions. But we are going to start with the wind, okay? So we're going to start with wind. I'm going to show you how it looks like. Let me make sure you can see. So here's my wind. Here's my wind rock. And if you guys can see this, I'm not sure if you can, but basically I drew a green line here, and this is just to represent like the rock shape, and we can see how far our sediment has spread. So I'm going to blow wind on it, and let's see how far it goes. Okay, so basically you guys can see here, I got a little bit of sediment to come off, but not that much, okay? So a little bit was able to come off there. So the next one we're going to look at is what if I have a glacier on my sediment? Okay, so this is going to be my glacier rock, where I'm pretending that we put a glacier on top of this rock. And remember, guys, melting water will help to produce erosion. So if I put a glacier, let's see what's going to happen. So here I got a little glacier, and let's just check it out. Let's see. My glacier is going to be an ice cube. So let's see. So it's in the hot summer sun, guys. So it is melting, but it's not producing that much erosion right now. But let's let it sit. I'm going to put this to the side for now, just to, can you guys see my, yeah, you guys can, good. I'm going to put this to the side just for now. We'll see what happens and see how much erosion it can produce. The other one we're going to look at in the meantime is liquid water. So this is my spray bottle. I'm going to give it a little squirt, and we're going to see how much erosion we can produce with liquid water. So here we go. So guys, in comparison to the wind one, this is definitely winning for erosion. You guys see how much erosion it produced? A lot of erosion. We're definitely scraping off a lot of that top layer of the rock. And you guys can see that here. That's why we get a lot of that brown stuff. I'm gonna move this up a little. There. You guys see how much erosion I got from my rock? Okay, a lot of erosion. And if we go back to the wind one, guys, look at how much erosion I got. Not that much, really. In comparison to this with the water, way more erosion. And then if I turn to my glacier over here, guys, he's still melting, but I'm really not producing that much erosion here. So it's going to take a long time to get any erosion. But with liquid water, we get erosion almost instantly. So here's the deal, guys. The point of my experiment there was to show you that liquid water is the most effective producer of erosion in real life, okay, in our experiment and in real life. When you put liquid water on a rock, an igneous rock especially, because that's what we're talking about when we're talking about erosion, you put igneous rock, when you put water on an igneous rock, guys, you're going to get the most erosion. With wind, it's effective, but an igneous rock with water on it is going to lose the most sediment, and that's going to help to produce the most sedimentary rocks. So even in nature, guys, water is the best eroder. Okay, so I hope you kind of learned something about that, because I know we talked about water and wind. We didn't necessarily talk about which one is better, which one's more effective at erosion, but now you understand that definitely water is the winner.